Hey you, it's me. Let's talk about binary search. What is binary search? Well, it's an O log n algorithm. That means that the worst case scenario for searching through an entire array would be in log time. Log is a function with a base, and it takes a value. It will return an exponent that is needed to turn that base into the given value. The exponent is just the power that we would raise the base to get the value. In computer science, 99% of the time when we say log, we're going to be dealing in log base 2. So we're almost always asking, to what power do we need to raise the number 2 to get this given value? An example of that would be log base 2 of 8 is 3, because 2 to the third power is 8. Why is log being used to model the complexity of a binary search? Well, imagine that you're searching for a value inside of a sorted array. You can find the exact midpoint of your array and compare that value to the value you're looking for. If the value that you're looking for is greater than the midpoint value, you can disregard the entire lower half of the array. Now you'll repeat that same step. You're going to find the midpoint of just this upper half of the array. And we'll ask the question again, is this midpoint greater than or less than our given value? We'll disregard half of the array again based on that answer. And you continue that until you either find your value that you're looking for, or you've gotten down to one element that's not the value that you're looking for, and so you know that the element is not in your array. We can actually calculate the maximum number of times we would need to half the array using the log of the size of the original array. If our array was size 16, we would half that to size 8, we would half that array to size 4, we would half that to size 2, and finally we would half that to size 1. At that point, we would know whether or not the value was in the array. Now, you can find the midpoint by saying your high index plus your low index divided by 2. However, that can actually cause something called integer overflow, which is basically when the variable that you have can fit only a certain size of a number, and you put a number in that's too big. So say our maximum integer that we can hold in our variable for the midpoint is size 12, and we add 9 and 6. 9 plus 6 is 15. But when we put it into the midpoint, it'll be reduced to 12 because that's all that it can hold. Then when we divide that by 2, we will get 6 for a midpoint as opposed to 7. We can do this a little bit differently and avoid integer overflow. It's as simple as high minus low, divide that difference by 2. Now we're going to add the low. And another thing to note when we're dealing with finding the midpoint is if you come across an integer that isn't whole, so it's like 0.5, we're always going to round down. It's okay because sometimes you're not going to deal with a perfectly even split. So it's completely fine to floor the number and go with a whole number instead of trying to figure out if you should round up or round down. Let's look at our LeetCode problem today. Number 704, binary search. Given an array of integers nums, which is sorted in ascending order, and an integer target, write a function to search target in nums. If target exists, return its index, otherwise return -1. You must write an algorithm with O log n runtime. When writing your binary search algorithm, the first thing that you're going to do is you're going to create your low and your high pointers. Low will always be at the very start of the array. Arrays are 0 indexed, so low will be equal to 0. Your high pointer is going to point to the very last element in the array, which in our case will be the length of nums minus 1. It's worth noting here that our low and our high pointers are inclusive boundaries. We'll use a while loop to search over this sorted array. And the condition for our while loop is going to be as long as low is less than or equal to high. What this is making sure is that our low and our high pointers don't cross. At some point, if we get to a single element, then our low will equal our high, so that is totally okay. But what we don't want to see is that low is now pointing to the upper half of the array, while our high is pointing to the lower half of the array. So that's literally what this is just making sure we stop at. The first thing that you want to do in your while loop is to find your midpoint. So remember, for us, that's going to be high minus low divided by 2 plus low. This double slash that you see here is integer division, and it basically just means that our number will be rounded down. The first thing that we can do is check if the midpoint is equal to our target. If num's index mid is equal to our target, we can just return our mid, because remember, the problem statement asked for an index to be returned. Else, if num's index mid is greater than our target, what we're going to do is we're now going to disregard 1/2 of the array. The way that we do that is we're going to take our high pointer and we're now going to move it to the other side of our mid. Because we've already checked mid, we know that that's not what our target is, so we can disregard it for the next part of our array. And by moving high just to the left of mid by 1, we now create the new half of the array that we're going to iterate over. Our else statement is implying that num's index mid is actually less than our target. If this is the case, we want to move our low pointer. We'll move this to mid plus 1, just one element to the right of our midpoint. This is because, once again, we know that mid is not our target, so we don't need to include it in our array anymore. Outside of this while loop, we're just going to return -1, because if we ever did come across the target, it would have been returned from inside of the while loop. So we can safely assume that if we made it through the entire while loop and we never returned, that the target does not exist in our array. And that is the most basic form of binary search. It requires a sorted array and for you to be able to access the midpoint. As long as you know how to get the midpoint, with high minus low divided by 2 plus low, you can go and find the midpoint and continuously compare your midpoint to a target and then remove half of the array accordingly. I hope this was helpful. Binary search is definitely one of my favorite algorithms to solve problems for. It's a very fast searching algorithm. So have fun. Thank you so much for watching. Don't forget to like and subscribe. Go ahead and leave a comment if there's a specific problem on LeetCode that you want to see solved, or if there's some sort of pattern or algorithm that you want to hear me go over. I really appreciate any feedback, and I love making these videos. It makes sure that I understand what I'm going over even more, so I hope that they can help you as well. Exponent, 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 the exponent, the exponent, 2 of the exponent, the exponent, 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 the exponent. I don't fucking, ugh.